In part 2, we're going to tackle the MPX decoder on this old Kenwood Trio, or in this case an AGS Trio. It's not receiving FM and stereo. In part 1, we fixed the bass control. Now we're going to get this thing working in stereo. Let's watch. Now, as you remember from part number 1, I was able to get the 19 kilohertz pilot tone that's supposed to be synchronizing the detector, but my composite signal with the 38 kilohertz sideband is the levels are wrong. So I think what we're going to have to do is change a bunch of capacitors in the MPX circuit as well as in the IF circuit. So I've just been doing some testing here. I don't find any solid state components that are bad. So I got to think it's got to be a capacitor issue. This should be the multiplex level over here. Aha, that's the multiplex level.
Nothing on the radio today.
For a chance to win the weekly 8 p.m. grand prize of $10,000.
Lips and keep them closed. Cross your what you made me do. What you made me do.
And tired.
Won't you hide?
Join at bcaa.com. BCAA. Membership is rewarding.
Good news and bad news from Go Dodge Surrey. The bad news is they have way too many new 2017 vehicles. The good news is they're selling them to you at cost. See a copy of the invoice, buy your new ride for cost, don't pay any extra fees, and free lifetime engine warranty. You pay what they pay. For example, get a brand new Ram Hemi 4x4 for only...
So after checking some of the alignment of the IF circuit, I've determined that I'm going to go and replace the capacitors in the multiplex circuit as well as the IF circuit. So we're going to change all of the electrolytic caps, and then we'll take it from there. I'm not going to tune anything until I get all the caps replaced. I may have to do some touch-up because some of the capacitor values that I'm going to put in are not identical to the original, because the original had 20 microfarad and 30 microfarad, and well, those are not standard sizes anymore, so we may have to go to a 22 and 33 and that type of stuff, or from a 40 to a 47, which will slightly change the tuning of the circuit. But let's go and change the electrolytics first and see if I can get this thing to receive in stereo. Aha, 11 ohms. It's a 10 microfarad, 16 volts. So worst case scenario is 8 ohms, and this one's coming up at 11. So this cap is bad. Let's just try a few of these electrolytics. This is in the input where the multiplex signal goes from the FM board, which is here. This is the FM IF, and it goes into the actual decoder board. And I'm thinking maybe my levels are a little off, and that's why it's not decoding. So we'll try a few of these electrolytics in here that look to be, they might be the culprit here. There's 3 of them in a row right here. That one, and that one, and there's actually another one over here. So there's 4 of them in this area here that could certainly create problems for the FM stereo decoding, especially if they go leaky or the ESR goes really high like that one has. So we'll try these one at a time and see whether it makes any difference to the FM. When I tried rocking some of the transformers back and forth, you know, a turn here and a turn in and a turn out, it didn't seem to make any difference. Like there's no tuning seems to do anything. So we have to have a component that's going bad on here. When I get it, this is two separate tones. So there'll be a 440 tone in the left channel, a 600 tone on the right. So when it does kick into stereo, we're going to hear it for sure. We're certainly going to hear it. So we'll just do this other one next to it here. I'm just going to do these two 10s first, and then we'll do the other ones. But definitely one of these ones here could certainly causes some problems, that's for sure. Now this capacitor that I'm soldering right now is directly on the multiplexed FM line going into the circuitry. And that one actually measures in spec 4.7, but it's old, and ESR isn't the whole story. We'll see what the capacitance measures on this thing here and see if it's lost capacity. That looks okay. 16 microfarads. Capacity wise, ESR wise, this one's okay, but for the sake of it, let's change it. Because as you can see, this one here is the direct input. So this one will have a direct impact on the quality of the signal getting into the decoder board. That feeds right into this transistor here, the first stage. So this one basically couples the multiplex signal into this first stage. I have a schematic that is not the exact one for this unit, but it is a later model, so the circuits are probably going to be similar. And that shows, there's a transistor here, that shows that there is a 10 microfarad capacitor, which that's what this is, going into Q1, which will carry the signal in. And there's a couple of other capacitors in here as well that I'm suspecting. This is the other one here, C14. This is the other one I changed, the other 10 microfarad. And if we look at the signal path that goes into the transistor and it comes back out of the transistor and it ends into this other, through this other capacitor going into this tuned circuit. And this is our circuitry here for the decoding and turning on the stereo light and stuff. So this circuit board here is not the exact one, but I think it's probably fairly close, because this schematic that I've got here, this one's from a TK40, and this receiver here is a TK30G. So this is a later model, but I think the circuitry is relatively similar between the two of them. I see a lot of parts that are of the same type of value, so signal coming into here. So this is the multiplex signal on the scope here. If we look at the scope, this is the multiplex signal coming in. If I just turn this down a bit, you'll see it's got the 38 kilohertz signal is actually modulated in there as well. That's what the wider portion of this carrier is. And this is going through the buffer. Here's going through that other second capacitor. It goes into this coil here. From here it comes down. And see, it's going into another transistor here. So that's those two capacitors replaced. There's also this other one here. So I'm going to change this one out as well. This one here, I don't trust it. I don't trust any of these old caps as far as I can throw them. They're old Elnas. This one here. Let's check out the ESR on this one. See how bad this one is. This one's a 30 microfarad. $33 ohms. It should be more like about 3 ohms. So we know this one here is bad for sure. For sure. There's that bloody dog. That's measuring like 100 microfarads. A little bit high. But the ESR is bad on this one. So this one here is, we know this one's bad for sure. I go find a 30 microfarad. Actually, it'll probably be a 33 because I haven't seen a 30 microfarad. I've never seen a 30 microfarad replacement. I'm not saying they don't make them, I've never seen one. So I have a new one here. It's a 33 microfarad. Get this one in here. In case you guys are wondering what I'm doing, I heat up the foil to let the component go through, and then I wiggle it. I twist it a bit as the solder is cooling. That way it doesn't stick. That way I can go and do the other side. It's a little trick I learned years ago. When if you don't want to use solder wick or a solder sucker to take off the solder on these plated boards because they've gone over all the traces with solder, sometimes it's just as easy when you heat it up and you stick the component through. Just roll it in your fingers to keep the wire turning as you remove heat, and it won't make a connection. Then when you heat the other land on the other side, you can push the part through, and because the first side didn't connect, didn't fuse to the board, you can push the component all the way down. Just a little tip when you're working on these boards like this that I've got tons of solder on them, and they'd be a pain to remove it all to try and replace parts. This just makes things just a little bit easier when you're working with these things. Okay, so that's those three replaced. Okay, we've got one more electrolytic on this thing to change. Is this one right down here? This is the last of the electrolytics on this board. That's this one. It goes right from here to this ground. This is a 50 microfarad. Let's just see how this one fares. I'm sure it's probably bad. Yes, this one's completely open. This might be the one that's causing the problem. You can see that's ESR on this one is just completely open. 50 microfarad, 15 volts. This is probably a filter. Let's just see what the capacitance meter says. This one should actually test open. The ESR is completely dry on this thing, so this thing probably doesn't even measure any capacity. And of course it does, but the ESR is shot on this one. So let's find a new 50. I have to probably settle for a 47. That'll be close enough. So once again, what I'll do is I'll put the component in on the positive lead in here. Like there. And I'm going to just heat up the board a bit. So I get the first lead through. And now the first lead's through, and I've twisted it a bit so now it hasn't stuck to the board. Now I heat up the other side, and I can push the component all the way down. Okay, let's see what happens. Oh, my antenna wires come off. Still nothing. I'm just going to just try rocking these transformers back and forth a bit and see whether we're just off tune a bit. I'm turning them no more than like a half a turn each direction using a insulated tuning tool. Okay, another cap that I found that's also bad on it is this one. It's right on the output of the IF board. C22 is also one that it's a 10 microfarad and its ESR is through the roof. So we're going to get another one of those. I've just got a dead carrier running now on this low end frequency here. The fact that I've been finding so many of these ELNA caps bad in the IF circuit, I'm just going to work my way back and change the other remaining ones and see maybe perhaps that's what's causing this thing not to pull in stereo reception, because they're all measuring bad. Just got to find it here so that I can remove it. I guarantee you this one's bad. I can just tell by looking at the rubber end on this thing that this one's bad. 11 ohms. That's getting there. Shouldn't be any worse than 8. I'm going to do the last 2 capacitors in the decoder board, which are right down here. Then all of the electrolytics will have been replaced on both the IF board and the S board. This is a preamp board here, and as is that one. One's a driver board for the power amp. This is the preamp board here. This is the driver board. Oscillator is down here. Your AM IF is in here. FM IF is in here. And the multiplex board. So there's 2 capacitors that I haven't done yet. I'm going to change these 2 out here, and that way any problem that's caused by a capacitor is will have been eliminated. So there's one. Okay, I think I'm recording now. As you can see, I'm very close. I got my stereo light triggering here, so I'm very close now. I've changed all the capacitors. I think it's just a matter of tuning this thing a bit to get this thing to stay. Well, this is really maddening, okay? I changed all the capacitors on this thing, and I'm pulling my hair out. Why is this bloody thing not receiving stereo? And I was listening to my test tone, right? And it sounded like the signals were mixed. I was just flipping through the stations. I thought, damn, the light comes on like on peaks, but on quiet stuff it's not lighting up. This sounds like stereo. So I went and I got some music that is in super stereo. This would be the Beatles, and this bloody thing is actually receiving stereo. Listen to this. I can't play this, but I'll let you guys hear it so you can actually hear, because what the Beatles did was, and a lot of the stuff, especially on albums like Rubber Soul, for example, they recorded the music on the left channel and they put the vocals on the right channel. It's perfect for testing stuff like this. Take a listen. Okay, and now the left channel. There's the bass, right? No singing. So we gotta shut this off for a bit here, because I don't really want to have any trouble. So we'll wait for the next song, because I put a few songs on here. This bloody thing is working. It's just the stupid light isn't coming on. So somewhere in the stereo detection circuit in this area of the board here that turns that stupid light on, something is not triggering it. But that bloody thing's receiving stereo, and I've been pulling my hair out on this thing for hours, trying to figure out why the hell is this light not coming on. And I'm assuming it's not receiving stereo, but it actually is. Okay, listen to this.
Well, I'd rather see you dead, little girl, than to be with another man. You better where I am. You better run for your life if you can.
Definitely receiving stereo. I know I'm getting stereo. Ah! There it is. That's it. That's it. It's stereo. It's working. Excellent. I don't want to play this but yeah, we got our stereo light back. So that's all it was just this coil was I mean, it shows where it was marked. I just had to turn it over about a third of a turn. Not even that. There's a dot here, right, where these were were the line from the factory, and I just had to tweak this one ever so slightly, and that seems to have solved my problem. Again, we can hear it very clearly here on the Beatles. My test tone doesn't show this effect as much because I've got 100% tone on the left channel, one tone on the left, and 100% on the right. This old circuitry isn't quite as good as the new stuff. I got them grinding pavement in front of my house here, but listen to this. I'll put some Beatles on here for a few seconds. You'll distinctly hear the difference in separation. Here's the left channel, or the right channel.
Had you come some other day, then it might not have.
And then the left channel.
But you see now I'm too.
You hear the bass on one channel, and the other channel.
Call your number on my wall.
Definitely it's working in stereo, and I've got my stereo light back here, right here, which makes me happy. So if I tune around the dial,
Post.ca/ship-free for details.
About 7 minutes.
okay, here we go. That's my
Course of explore the complex relationship.
that's a mono station.
Narrator.
Stereo.
You could be off to the grand.
Sidney
Mono.
Crosby tells me to take the final shooting.
There we go. I love it. Love this old technology. Get it back working again. So what we've done on this one is we've just to recap this one. What I've done on this is I have recapped, just a recap. We're going to recap what we've done on this one. I recapped the IF board. So I changed these capacitors here, 3 of them here on the FM IF board. And I also changed all of the electrolytics here on the MPX board. And I did have to tweak the coil here. I had to tweak a couple of the controls here just to align it, but it wasn't off by much. I had to move this here about 1/4 of a turn, and that's basically the only one I had to adjust. Everything else, nothing else was touched on, and everything else is stock. And this unit is
It's the details that matter.
now ready to go back to the owner. So let's put it together and see how it looks once it's back together. And there the unit is back together. Sorry about all the racket out there. As I say, they're I'll show you what they're doing. They're cutting the pavement to put a new water main in. So it's going to be interesting to see where I can park. They're going to dig up the whole street in front of the house here and put a new water main in. Water main last year blew up right in front of my driveway and flooded me, so it's 100 years old, so time for a new one. So I got to put up with some noise for the next couple weeks, and getting access in and out of my driveway is going to be interesting. Anyway, thanks for watching. Hope you enjoyed this restoration of this old AGS Trio. Of course, Trio, as we all know, later became the Kenwood company. Kenwood bought out the Trio brand from AGS. This was American General Supply. It was made for them. It was made in Japan. Hope you enjoyed this. This version that you guys are watching on the regular channel is the shortened, condensed version of this. The Patreon viewers, you guys get a treat when I release the full version showing the full restoration, because this thing's been here for a few weeks and I've been working on and off this thing for several shots at it to actually find the problem with it. And I know that it looks simple, just changing the caps, but there was actually a little more involved than that. So Patreon viewers get to see the whole thing. Thanks for watching.